Hey, what's up, guys? Okay, so welcome to my second video about a partition. Okay, so in this video that I want to previously, I think I talked about the Pentagon theorem, and so in this video about next, let me just give the very upper bound of this P of n. Okay, so this video is just upper bounds of P of n. Okay, so simple definition of P of n is just the integer partition, but another definition which will be very trivial or very simple is that we do the infinite product, right? And let's define so I can define a P of n to be the power series of this guy, and the upper bound is that P of n is less than exponential k square root of n, where k is pi times square roots 2 divided by square roots of 2 divided by 3, 2/3. Okay, so if you go back to your first year, right, in the undergraduate, then how can you prove these things? So the first question is that how can you prove these things? Okay, so this power series product, right, very hard to estimate. So what is the technique that one can try to prove it? So this is proving is interesting. So I think one can learn a lot from understand this. Well, let's write this f of x. Okay, so yeah, so simple observation is trivial that p of xn less than f of x, because we know that p of n is greater than 0. Okay, and so let's take the log. So we get log p of n plus n of x log x equals less than log f. Okay. Okay, so now let's compute log f. So log f is simple, right? Log f just log minus log infinite product of n from 1 to infinity 1 minus xn. Also, we can do summation. We can do the expansion. So the infinite product between become infinite sum. So this is a very good technique that one can just use it. Okay, and we can run it. Okay, and we use that log 1 minus x is a summation of x m from 1 to infinity. Okay, so you get the n from 1 to, oh, by the way, 1 minus xn. Okay, so there's a 2 minus sign, right? So there's a right. So sorry, there's a minus. I think there's a minus sign here. Okay, so you get the n from 1 to infinity, n from 1 to infinity, and the x m n m. Okay, so you can take out, you can change the. This is non-trivial, right? Because you are not allowed. You're not sure whether this is a converge. This double series can exchange, but let's first neglect this technical issue. Okay, I mean you can prove this because you can prove maybe this is absolute convergent. Remember that let's consider x is less than 1 and greater or equal to 0. Okay, so you get 1 over n and let's say summation n from 1 to infinity x m n. Okay, so this is the geometry series. So you get the summation n from 1 to infinity 1 over m xm 1 minus xm. Okay, so what's the next step? The next step is let's say we want to estimate this, right? We have this and we want to estimate. Okay, this is not difficult. So notice that we get 1 minus xm, 1 minus x will be 1 plus x squared, xm minus 1. Okay, so let's consider this. So what we have is that mxm minus 1 will less than 1 minus xm, 1 minus x, because for this type, right, I can choose. So x is less than 1. So xm minus 1 will be the smallest term in this sum. So I can replace it. And for this one, I can replace m because 1 is the largest sum. Okay. So you start from here and then you divide it by, you just make a change of variable or just change a little bit, and you can get this 1 over m squared xm 1 minus x less or equal to 1 minus m, 1 divided by m, xm 1 minus xm less or equal to 1 minus m squared, x 1 minus x. Okay, so you can start from here and then doing here. Okay, this is not difficult. You first reverse it and divide by 1 over m or 1 over m squared, and you get the following. Okay. Okay, so now now you can see these terms. Right? These terms is the same as these terms. Okay, so you can easily set m from 1 to infinity, and then you do the 1 over m squared summation. Okay. So our f is less or equal to x 1 minus x summation m from 1 to infinity 1 over m squared. So this is a standard Parseval series, or basically the famous Euler result is pi squared divided by 6. I mean, I have at least 4 ways to prove this pi squared divided by 6. So let's neglect it. If you don't know how to prove this, and you can check out my video. Okay, so let t to be x divided by 1 minus x. Okay, which tell me that sorry. So let's let t. Let's let t to be 1 minus xx. Okay, so since x goes to this from 0 to infinity 1, so it means that t can go from infinity to 0. Okay. Okay, so our goal is to estimate this. Our goal is to find a way to estimate. Well, this is not difficult because what is the 1 plus t? It's just 1 over x. Okay, so this tells me that log 1 over x is less than t. Okay, so let's go back to original results. We get log pn plus n log x less than log f. So we get the log p of n less than log f of x plus n log 1 over x. Because we can just divide it, we can just change this to the right hand side and divide by 1 over x. Okay, so we get this one. Okay, so now this guy less than pi squared divided by 6t plus nt. Okay, because let's say this is okay, so you can see that this 1 plus t is 1 over x. So this term is less than t, right? Less than nt, and then this log f by our computation is t pi squared divided by 6. Okay, so nice. Okay, so amazingly. Okay, so we get log p of n less or equal to pi squared divided by 6t plus nt. Okay, and the t is 1 minus x divided by x. Okay, so x can be changed. X can choose any from 0 to 1, right? So the only thing is that you just need to what? Minimize this, right? So you just minimize, because this equation is correct for any x, so which is correct for any t. So we just minimize t. Okay, so we minimize t. We choose a t such that this function is minimized. Okay, so obviously this is trivial, right? Because you just do a derivative, and the simple ways here, you just use the arithmetic and the geometric mean inequality. So pi squared divided by 6t plus nt greater or equal to square root of divided by 2 greater or equal to pi squared divided by 6t times nt. Okay, which is pi squared divided by 6n. Okay, times 2. Nice. Okay, so log p of n less or equal to what? To 2 to what? Okay. So 2 times pi squared divided by 6n. Okay, so which means that your p of n less than exponential squared 2 times square root of pi squared divided by n. Okay, so let's go back to see whether it's true or not. Okay, so this is exponential k square root n, and the k is what? K is a pi 2 divided by 3. Yeah, I think so. I think this is true. Yeah, this is true. Yeah, nice. Yeah, so we prove. Okay, so very simple derivation. And there is another phi version. Yeah, let's talk about phi version. Yes, there's a phi version that you can check it. Is that the phi version can prove the following. You can prove that the square root of n, and there's another factor pi divided by square root of 6 minus 1. So this is the more fine version. But the reason is the following. So I know that the P of K, I know it's partition, so P of A greater or equal to P of N if K greater or equal to N. Okay, so if this is true, then I get f of x, which is greater than P of K, xk. Let's say k from 0 n to infinity, right? Because I only take out the n term, which is greater or equal to summation P of N x to the k from n to infinity, because I know that P of A k greater than n if k greater than n. So these guys are just a geometric series. So we get P of n x n 1 minus x. This is 1, okay, 1 minus x. Okay, then let's take log. So we just take log. Okay, we just take log. Okay, so if you take log, which you get the log Pn. Okay, less than the log f of x. Okay, you get log p, right? You just take log for both sides, and so you log Pn less than log of x plus the next term, like n log x, right? But let's reflect it, so you get n log 1 divided by x plus log 1 minus x. Okay, so you just plug it. Okay, and the next things, the next thing that you need to do is just do exactly the same thing. You just set 1 minus x divided by x equals to t, and you can so this term is already fixed. It's the same as this, right? So this log f is less than pi squared divided by 6t, and then this is nt. But you get this term, right? You get which is log t. So this log 1 minus x will give the next term. So log t minus log 1 over x. Okay, so you can get you can just neglect this term, and because log 1 over x is t, right? So basically you can just change this to, you can just combine this. So you get n minus 1t plus log t. Okay, so this term is pi squared and minus t plus log t, and which is a little bit, slightly less than this, right? Because this guy, you pi squared divided by 6t plus minus 1t plus log t. So this term is less than this because there is you minus another t, but you only add log t. So this is the more fine version compared to previous one, and then you just do exactly the same thing. You just minimize, find t such that you minimize this function. Okay, so simple proof, you can get t is minus 1 plus 4 and minus 1 pi squared divided by 6 divided by 2 and minus 1. Okay, then you just plug it back. So this is just a simple calculation that I don't want to do, but you plug it back, then you can get this more fine version of asymptotics. Okay, so next time I will prove the Jacobi triple identity, and see you guys next videos.